Hey, ninth graders, we are looking at page 40 in your math binder. So if you don't have it out already, please pull out page 40. It is titled Solving Compound Inequalities. We're going to start by filling in these blanks at the very top. A compound inequality is an inequality that is formed by the union, parentheses, or the intersection, which is and, of two simple inequalities. So every time it's talking about an intersection, that's going to be where two things overlap. And there will be that, I don't know, I'm using my hands like this. There'll be that graph with the shading in the center. It's where two things intersect. Union would be this section or this section united together, where it's going to be one or the other. So intersections will always look like this. It'll be A, which is any number, is less than X, which is less than B. They will also look like this. X would be greater than A there, and X would be less than B. I kind of wrote that down below because my handwriting was getting kind of big and I ran out of space. Okay, so this is saying, I just want to explain where the connection here is. See how X is less than B? Right here, X is still less than B, but you have to read it backwards when you say X, and then that's the great side, greater than A. So even though it says A is less than X, A being less than X is the same thing as X being greater than A. Okay, so both of these work great. I kind of like it better when it's written like this because it like puts it all together in one big thing. An or statement. Oh, one more thing I want to point out here. Put a star there, and then I'm going to put a star up here. The word between. Can we say between? We've talked about the word between a couple times. Remember Hachiro, where he was trying to figure out if he could ride that ride when he was the same height as one of the limits when it said between this and that? Well, between does not include endpoints. So between will not have equal to's on them. Between will not have equal to. Between is not equal to. Between is not equal to. And one more thing. Between is not equal to. All right, please don't let that screw you up on tests. So a store is offering a $30 mail-in rebate on all color printers. Luis is looking at different colored printers that range in price from $175 to $260. Solve the following compound inequality to determine how much Luis can expect to spend after the rebate. Okay, so let's begin by solving this thing. Now, this says 175 is less than or equal to X plus 30, which is less than or equal to 260. Because remember, the mail-in rebate is something that he's paying full price and the rebate would come back and knock that price down by 30. So he's paying his sale price plus the $30 that he's hoping to get that mail-in rebate for. But regardless, I want to show you how you would solve an equation like this. Now, typically, I tell you to separate the two sides. Here's where that gets very helpful. You don't have two sides on this inequality. You have three sides. You have the left, the right, and the middle. And I need you to separate this. Even if you hate separating them, at least like humor me and do this today. All right, let's find where the variable is. X is in the center. Notice I'm covering up the two other sides so that I don't screw this up. X is being added to 30. How do you undo adding 30? Well, the inverse of adding 30 would be subtracting 30. So underneath where it says plus 30, I'm going to undo that by subtracting 30. On an equation or a regular inequality, I would do that on both sides of the equal sign. Well, here, I have to do it on all three parts of the equal sign. So I'm going to subtract 30, subtract 30. Now, 30 minus 30 is 0. So in the center, I have only X. Now, on the right side, 260 minus 30 is 230. 175 minus 30 is 145. And then, did we multiply or divide by a negative number? No, we just subtracted 30. Now, the only time we would change this symbol is if we multiply or divide by a negative, because you know multiplying and dividing by negatives reverses the symbol for an inequality. So this stays less than or equal, and this one stays less than or equal. Now that's my final answer. But if I were to go up to Louise and say, all right, Louise, 140 is less than or equal to X is less than or equal to 230. Louise would look at me like I'm crazy because it doesn't make sense. So go back to what the question asked. Solve the compound inequality to determine how much Louise can expect to spend after the rebate. So let's tell Louise how much he's going to expect to spend from this to that. Louise will spend from $145, I forgot my dollar sign, to $230. Notice I did not say between $145 and $230 because remember, between does not include the endpoints and I have equal to's here. So I have to include those endpoints. I know it's super picky of me. That's the end of the sentence. Okay, question number 2. About 20% of the time you sleep is spent in rapid eye movement, or REM sleep. That means that when you're sleeping, by the way, you like stare at someone while they're sleeping, which is creepy, but also kind of cool to look at because their eyeballs like twitch very slightly. It's called rapid eye movement, and it means that you're in a very deep sleep, which seems weird when you're sleeping deeply, your eyes twitch. But it's like when you're dreaming, your eyes move rapidly. Anyway, you spend about 20% of your time sleeping in REM, which is associated with dreaming. Solve the following compound inequality to determine how much time is spent in REM sleep for an average adult. All right, let's start by separating our inequality into 3 sections. How do you undo dividing by 0.2? Well, the inverse operation of division would be multiplication. So I'm going to multiply by 0.2, multiply by 0.2, multiply by 0.2. If you think you're too good to show your work, you're very much wrong, okay? You're going to show your work, so show your work. All right, 7 times 0.2. If I type that in my calculator, 7 times 0.2 is 1.4. So I have 1.4. And then notice I didn't multiply by a negative 0.2, so that symbol stays less than or equal. And this one stays less than or equal. In the center, 0.2 times 0.2 being multiplied and 0.2 being divided, those undo one another, they become 1. And in the center, you just have x. Then 8 times 0.2 gives me 1.6. All right, so there's my inequality, but I have to put this back into words for my final solution. So it said about how much time is spent in REM sleep for the average adult. So I would say from, because remember I have to include those endpoints, from 1.4 to 1.6 hours. That doesn't seem like a lot of time in like a deep sleep. Okay, solving and statements. Today we are focusing first on and statements, but then we also are going to look at some that are or statements. We'll solve them and then we will get them graphed. Now, and statements are going to be very similar to what we saw up above. So let's solve this first one. Do you notice how this one's written differently, the ones up above, than the ones up above? So let's be careful as we solve this thing. I'm going to separate this. And I know that I want to get the letter n all by itself. So how do I undo subtracting 1? Well, I add 1 to both sides of this inequality. So I have 6n, negative 1 plus 1 is 0, is greater than 11 plus 1 is 12. My last step would be dividing by 6 on both sides of the inequality. So divide by 6, divide by 6. That's not a negative 6, so my symbol stays greater than. I have n is greater than 2. All right, then on this side, I need to get n all by itself. I'll start by adding 10 to both sides of the inequality. I have negative 9n is greater than negative 90. My last step to undo multiplying by negative 9, I'm going to divide by negative 9. Negative 90 divided by negative 9. Pause. Do you notice how I divided by a negative on both sides of the equal sign? What happens when I divide by a negative? That greater than symbol. It becomes a less than symbol. Okay, so greater than became less than because remember I had to reverse the symbol in the middle. Negative 90 divided by negative 9 is positive 10. If you were to give me this for your answer, I would mark it wrong because this word got lost. Now on these other problems up here, it was an and statement, but we didn't have to write that word because it was written as one consecutive and statement. On this one, and was written in the original equation or inequality, so I have to write it down below, and I'm going to write it right here. And n is greater than 2 and n is less than 10. So this is my solution. Now, being greater than 2 and less than 10, what does that look like on the graph? Well, I'm going to go to 2 first. And notice it just says greater than, so I'm going to do an open circle at 2. Greater than 2 is going to shade above. I'm also going to do an open circle at 10. At n being less than 10 means shading below. So I'm going to be above 2, below 10. That's just shading the space in between, like this. Okay, so it looks like this. That interval notation would be 2, 10, with open parentheses on both of them because neither of them had an equal to on them. And they both were just written like that, and the graph was not filled in there. Now, one more way that you could have written this and gotten it correct, you could have said 2, 10, put the n in the middle, and both of them have inequalities like this. These are the same answer. Just keep that in mind. Okay, so I want to write something over here in the question/notes. It's going to be more of a note. I'll start with writing and. When you have an and statement, and I'm going to give it like a zigzag underline. An and statement, for example, I'm going to have it start at a circle and then filled in and ending with a not filled in circle. So this is an example of an and statement that would begin at the number 2 and end at the number 11. An and statement will almost always be shaded just in the middle of these 2 dots. So the inequality of that would look like this: 2 with x or n or whatever in between, and then 11 up above. Remember, 2 is less than x, or you could say x is greater than 2, but x is also less than or equal to 11. You can notice that that filled in circle at 11 translates to being a less than or equal to symbol with the line underneath our inequality. Okay, then the third way that this can be written is our interval notation. From 2 to 11, but you're going to have an open parenthesis at 2 and a closed parenthesis at 11. So that is what I want to have for our and statements. And once we finish an or statement, we'll put a note on the bottom about or. Okay, so problem number 2, why don't you split this thing into 3, push pause, and I'd like you to try to solve this one on your own because we'll solve it together in just a moment. All right, hopefully you had a chance to try that. I'm going to start by subtracting 11, subtract 11, subtract 11 from all 3 parts of this inequality. 19 minus 11 gives me 8 on the left side. I didn't divide or multiply by a negative, so that's still less than. The 11 minus 11 is gone, so there's just a 4m in the center. Less than or equal, and on the right side, I have 48. Last step, to undo 4 times m, I'm going to divide by 4, divide by 4, divide by 4. That's not a negative 4, so my inequalities stay less than and less than or equal. The center, 4 divided by 4 is m, 8 divided by 4 is 2, and 48 divided by 4 is 12. There's one of my 3 answers. My inequality, 2 is less than m is less than or equal to 12. So I know that it's going to go from 2 all the way up to 12. 2 is going to be an open circle, 12 a closed circle because there's an equal to on the 12. And an and statement would shade between those. My inequality or my interval notation would start at 2, go to 12, open parenthesis at 2, close parenthesis, at 12. Okay, that is our and stuff. Let's go to an or problem. On this or problem, it's going to be kind of like the first problem we did with and, but instead of the word and in between, it's going to be or, and the graph will look slightly different. So we've got 12x minus 10 is greater than 62, or 5 minus 9x is greater than or equal to negative 13. I'm going to ignore the second one. I'm going to solve the first one completely. Okay, so we're ignoring the second inequality. We're going to solve the first one. I'll begin by adding 10 to both sides of this inequality. So I have 12x, remember negative 10 plus 10 is 0. I didn't multiply or divide by a negative, so that's still a greater than. 62 plus 10 is 72. Last step, I need to divide by 12 on both sides of this inequality. That's a positive 12, so my inequality stays greater than. And I get x is greater than 72 divided by 12 is 6. Now I'm going to write the word or here because I don't want to make the mistake where I forget the word and then I get the whole problem wrong. Okay, over here, I'm going to separate this onto 2 and I'm ignoring the first inequality now. I'll start by subtracting 5 on both sides of this inequality. 5 minus 5 is 0, so I have negative 9x is greater than or equal to negative 18. I kept it greater than or equal to because I didn't multiply or divide by a negative number yet. Dun, dun, dun. Just kidding, it's not that crazy. Okay, now we're gonna divide by a negative 9. Ding, ding, ding. That means I need to reverse the symbol in the middle. When you multiply or divide by a negative, you flip that. What used to be a greater than or equal to symbol is now going to be a less than or equal to positive 2. There is my final inequality. Now remember, ors look like this. They point out. So I'm saying x is greater than 6. I'm going to do an open circle at 6. And I'm saying greater means shade above. Or x is less than or equal to 2. So I go close circle at 2 because it's the less than or equal to. And less than means shade below. My interval notation would say from negative infinity, open parenthesis, comma, 2. And since that's a filled in 2, it's got a closed parenthesis, or open parenthesis for 6 because that's an open circle, comma, infinity. All right, let's write some facts about or statements. Over here, I'm going to say or, give it a little zigzag underline because it looks so nice. Here's our example. Last time I said from 2 to infinity. This time I'm going to say lower than 2. Sorry, I said 2 to infinity. That was 2 to 11. This time I'm going to say higher than or equal to 11. So this is what our or statements are going to look like. It doesn't point inward, it points outward. Okay, so what does that look like as an inequality? Well, the shading is lower than 2. You would just say x, the shading, is less than 2. Then that gap, you need to say the word or. Then you can say the other shading, x, would be greater than or equal to 11 because it can equal 11 and it can also go higher. So this graph would match up with this inequality and then it would match up with this interval notation. Negative infinity because the arrow goes toward the left, comma 2, open parenthesis, or 11 with a closed parenthesis to positive infinity. Remember, you can never have positive infinity on a left side of an interval. It always goes toward the right, which is why it looks just like the graph when you line the two up next to each other. All right, let's try problem number 4. Push pause on your screen. Do your best. And I'm gonna have you unpause it in just a moment and let's see if you can get this correct. Remember, I'm going to ignore the second inequality. I'm going to begin on this first inequality by subtracting 1. So I have 3p is greater than or equal to 12. Last step, dividing by a positive 3, so the interval, or excuse me, the inequality stays greater than or equal to, and that is 4. Now remember, this is an or statement. I got to put that word or there, otherwise I will forget later. Over here, I can subtract 7, subtract 7. By the way, if you don't have space over here, use a separate sheet of paper. Try to make it fit somewhere else, or use like further to the right if you need to. So 7 minus 7 is 0. I have 12. P is less than negative 17 minus 7. 18, 19, 20, 21, 22, 23, 24. Okay, so negative 24. Whew, that's going to divide nicely. Divide by 12. Divide by 12. This is a great question. Do I flip the symbol? Remember how I said when you multiply or divide by a negative? Well, here you're dividing by 12, but there is a negative 24 up above that. That does not flip the symbol because you're not multiplying by a negative on both sides. If the 12 were negative, then we would reverse the symbol and make that greater than. But since the 12 is positive, it stays a less than symbol. Hopefully that cleared up a confusion for somebody out there. That would be P is less than negative 2. So here is my final answer for my inequality. P is greater than or equal to 4. So I'm going to put a closed circle at 4, shade above. P is less than negative 2. So an open circle at negative 2, shade lower. My interval notation, just like all of my or statements, will go from negative infinity to negative 2, open parenthesis, or 4 to infinity. Ooh, that was a lot of information. And I just shouted all of it at you. Let me know if you have any questions. Let me know if you're feeling confused. Try this homework problems that go with this notes, and hopefully using your notes will help you on this assignment.